Hello, you are most welcome. I'm Teacher Ivan from Una Educational Services. Today we shall be looking at the density calculations. We looked at the density, how we get density of different substances. We looked at the conversion of density units. So let us look at the calculations involving density. However, before we continue, please, I kindly request you to subscribe to all our YouTube channels from Una Educational Services, which include Una e-learning platform, Una Kids platform, and the Teacher Ivan's online class. Thank you. Don't forget to hit the bell such that you get notified whenever we post new videos. Otherwise, here at Una Educational Services, we make your learning simple, easy, and convenient. Thank you. Density calculations. We looked at the density of a substance being given as the mass of the substance over its volume. From this formula, we can solve as many problems as we can. So this is our first problem, which says, what is the mass of 1.5 liters of water? So from this, we are given the capacity in liters. Automatically, we know the density of water. So the trick here is we shall change the 1.5 liters to volume, whereby 1 liter is equivalent to 1,000 cubic centimeters. Therefore, 1.5 liters will be equivalent to 1.5 times 1,000 cubic centimeters, hence giving us 1,500 cubic centimeters. So this is the volume of the water. So since we have the volume of the water, we know the density of water as 1 gram per cubic centimeter. Therefore, from density of water equaling to mass of water over volume of water, we can find the mass of water. That is, the mass of water will be given by, we shall multiply it out by the volume, hence giving us mass of water as density of water times its volume. Therefore, we have the density, we have the volume, so we can get the mass of water as 1 times 1,500, and this will be in grams. Hence, the mass of water is given as 1,500 grams, or we can change this to the SI units, which are kilograms, by dividing through by 1,000. That is, we shall get the mass of water as 1,500 over 1,000, giving us 1.5 kilograms. So that is how we shall get the mass of 1.5 liters of water. Let us go to our second calculation. We are given a perspective box having 6 centimeter squared as the square base, which contains water to a height of 10 centimeters squared. So, if assuming this is our box, it has a base, a square base, meaning the dimensions of the base are the same. So if this is 6, this is 6, 6, 6. Therefore, for us to be able to get the volume of the water in the box, we are told that the water is at a height of 10 centimeters. So, finding the volume will require us to get volume using the base area from length times height times width. But since it has a square base, the length is the same as the width, and this gives us the base area. So we shall have 6 times 6 times the height, which is 10, giving us 360 centimeters cubed. So that is the volume of the water in the box. Then let us look at our third calculation. This one says the oil level in a burette. The oil level in a burette is 25 cubic centimeters. 50 drops of oil fall from the burette. If the volume of one drop is 0.1 cubic centimeters, then what is the final oil level in the burette? Remember, how does a burette work? A burette is a long, narrow glass tube with a tap down. It is calibrated but the measurements are in an ascending order. That is, could be from 0 up to, let's say, 50. So if it was at 25 centimeter mark, or say 25 cubic centimeter mark, that means that as the oil drops fall, then it will be increasing from 25 to a figure greater than 25. Now, we are told that there were 50 oil drops that were given out. So, they want us to find the final oil level in the burette if each of the 50 drops had a volume of 0.1 cubic centimeter. That is, let us first find the total volume of the 50 oil drops. We've seen that one drop has 0.1 cubic centimeter. What about the 50? The 50 drops will have 50 times 0.1, giving us 5 cubic centimeters. Then that means that if it was at 25, then we shall add 5 to 25. That is, we shall say final oil level is given by 25 plus 5. This is in centimeters cubed, giving us 30 centimeter mark. So it means that the final oil level in the burette was 30 centimeter mark. Otherwise, initially, the oil level had dropped from the 0 centimeter mark to 25 cubic centimeter mark. When 50 drops, each of 0.1 centimeter cubed, fall, then the oil level will drop from the 25 centimeter mark to 30 centimeter mark. So this will be our new oil level in the burette. Otherwise, thank you. That has been some calculations involving density. Please don't miss our next lesson, which will be density of mixtures. Thank you. Don't forget to subscribe.